Hi everyone. Today I'm going to explain about Twitter Tweet Sentiment Analyzer application, which has been designed to classify the hate speech upon training the Twitter tweets. In this project, we have set out to achieve several aims that focus on developing a robust hate speech classification system. Our first aim is to develop an NLP based hate speech classification system that is specially designed for Twitter. Secondly, we aim to evaluate the effectiveness of different NLP techniques and models in detecting and categorizing hate speech accurately. One of our key aims is to contribute to the knowledge of hate speech detection on social media platforms. Lastly, we strive to provide insights into the strengths and limitations of existing approaches and contribute to the development of more robust hate speech detection systems. Moving further, we have defined several objectives that will guide our development process and ensure the effectiveness of Twitter Tweet Sentiment Analyzer. Our first objective is to collect and pre-process a representative data set of labeled hate speech and non-hate speech comments from Twitter. Next, we will implement and compare various NLP techniques and models for the hate speech classification. By exploring different approaches such as deep learning models, rule based methods, or ensemble models, we can identify the most effective techniques for accurately detecting and categorizing hate speech on Twitter. To enhance the classification performance, we will explore the use of speech lexicons and dictionaries. These resources can provide valuable insights into the language and patterns commonly associated with hate speech. And also, training and fine tuning the models using appropriate feature extraction techniques and linguistic resources is another objective. We will evaluate the performance of our models using the standard metrics such as accuracy, precision, recall, and F1 score. These metrics provide quantitative measures of how well our models are able to classify hate speech and non hate speech comments. In order to provide a user friendly experience, we aim to develop an intuitive interface for hate speech classification with real time feedback. Lastly, we will create informative dashboards that present hate speech statistics, trends, and sentiment analysis on Twitter. These dashboards will provide users and the organizations with valuable insights into the prevalence of hate speech, emerging trends, and the overall sentiment landscape on the platform. So, before feeding any text data into a model, it is essential to clean and pre process the data. This involves several steps. So, firstly, removing at the rate mentions. These are generally used in social media platforms and do not contribute to the sentiment of the text. So, I have removed those at the rate mentions in my text, and also I have removed the numbers which does not carry any sentiment, and also the special characters which can cause the noise in the data and do not contribute to the sentiment. And I have also removed the unnecessary HTML tags and the hyperlinks which are present in the data. The first algorithm that I have used in order to train the data is by using Word2Vec algorithm along with LSTM. Now let's get an overview about Word2Vec algorithm, which creates the word embeddings and captures the semantic relationship between words. It revolutionized the natural language processing by enabling machines to understand the human language. It has given two architectures. One is continuous bag of words and the other one is skipgram. The continuous bag of words will try to identify the target based on the context of the words, whereas the skipgram does it in a reverse order. And coming to the LSTM is also known as long short term memory, which is a type of recurrent neural network that overcomes the vanishing gradient problem by incorporating memory cells and gating mechanisms. This makes it deal and ideal for tasks involving time series data and natural language processing. For our experiment, we trained the model on 30,000 tweets equally distributed between positive and negative classes. Although the training epochs were set to 100, we stopped the training at 20 epochs using callback methods because the model was overfitting. At 20 epochs, the model achieved a training accuracy of 76% and a validation accuracy of 74%. Now let's discuss about the second model that we have used in order to train the data. The second model that I have used is using BERT embeddings and artificial intelligence. Let's get an overview on these both. So the BERT, which stands for Bidirectional Encoder Representations from Transformers, is a pre-trained language model developed by the Google. It has transformed the way machines understand human language by learning context-rich word representations. And coming to the deep neural networks, these are the machine learning models that can learn complex patterns from the data, and they excel at learning hierarchical representations and are pivotal in applications like image recognition and natural language processing. Again, the model was trained on 30,000 tweets of each class, and the training was stopped at 20 epochs to avoid overfitting. And this model has achieved the training accuracy of 76% and validation accuracy of 74%. The third model that I have used is the BERT uncased model, which helps us to enhance the sentiment analysis with pre-trained contextual embeddings. So the BERT is a pre-trained model on large corpus of English data, and it has two objectives. One is masked. Here you can see some of the metrics and the visualization graphs that are obtained after training the models. And by using this model, we have gained an accuracy of 83%. So out of the three models that I have developed, I have considered the best model in order to detect whether it is a hate speech or not and integrated it with my web application. So here, upon giving a tweet, the application is capable of categorizing it whether it is a hate speech or not. And also I have given different hyperlinks which will help us to navigate to the models and also explain about the model, and we can also see what all metrics that we have received upon training the model. In this example, we can see that upon giving a positive tweet, the model has classified the output as a positive one. That means it is a non-hate speech tweet that we have given. So for this, I have used an emoji for the representation where the emoji is pointing its hand upwards, the thumb upwards, which means that it is a positive tweet. And in this example, we can see that upon giving a negative tweet, the emoji is showing its thumbs downward, which means that it is a negative example of hate speech. So for the data on which my models are trained, based on that, I have created a word cloud, which is a data visualization technique which is used for representing the text data in which the size of each word indicates its frequency or importance. Significant textual data points can be highlighted by using the word cloud. So here you can see two images. The image on the left is showing the positive words that are used upon the tweets, and the right image shows the negative words, that is the hate speech words that are used in the Twitter tweets. Now let's talk about the achievements of this project and the next steps. This project has successfully achieved several key milestones. We have developed three models using different techniques, demonstrating a deep understanding of advanced NLP approaches. We have also created an intuitive user interface that allows user to interact with the sentiment analysis system. We also conducted thorough testing and evaluation of each model's performance using relevant metrics. We have also addressed ethical considerations by ensuring data privacy, transparency, and bias mitigation. Although the original project description outlined three models, a decision was made to focus on one of the three mentioned models due to their effectiveness in the context of hate speech detection. And always there is a room for improvement, and here we are focusing on improving the UI by fixing the minor bugs and also trying to improve the model's performance for the models for which the accuracy is less than the expected ones. Here are the references that I have used in this project. Now let's have a look at the demo of the application that I have developed. So the application is developed upon the best model out of the three that I have explained, so that we can give the best output. Best performance model, the application is developed. So here, upon giving the tweet, the model will classify whether it is a hate speech or not. Now let's try different examples for it. So first I'm trying to give a positive input, and it will classify it as a positive one by showing the emoji which is pointing upwards. And if, for example, if I give any negative tweet, then it will classify it as a hate speech by showing an emoji which is pointing its hand downwards. And also I have developed other tabs which will navigate and give an overview of the models that we have developed. So there is an overall overview about the model and the graphs, and also it also gives the evaluation metrics that is obtained. Similarly, for the next two models also I have developed the same. And then I have also given the word cloud which will display which word has been frequently used in the data set. So the size of the words will describe whether it is most frequently used or least frequently used. So I have created two word clouds. One is for negative data and the other one is for positive data.